In this lesson, we shall actually look at mathematics for intermediate phase 2, and it is called the MIP 1502. And we shall spend time on a lot of questions, some of which pertain aspects of numbers, factorization, geometrical shapes, the square roots, distances, and so on and so forth. And we proceed as we get started. Right, there are lots of questions, but tons of questions we shall do today. And we proceed to solve them step by step. Represent the real numbers from 2 to 7 inclusive. Insert builder notation for 2 marks. How do we do this? Right, so we need to write this in set builder notation.
Yes.
So set builder notation. So now, in set builder notation, you can write like an X like that and indicate that these are real numbers. So what you do is you write an X like that and you indicate that the X here is an element of what? Is an element of real numbers, because now we are representing the real numbers, right? So X is an element of the set of real numbers such that now X itself lies between 2 and 7 inclusive, meaning you have the equality there. And this here is the set builder notation, or you can say X is an element of the set of real numbers such that 2 is less or equal to X, less or equal to 7. This is the set builder notation. So these are the things you need to know. Okay, so this is very important.
Okay.
This is called here the set builder notation. Okay, we're good. This is recorded. And in the end, we shall send you the recording. But the quality of the sound is always perfect on the recording. By and large, it actually is such that you're able to hear very well. You can watch this again and again and again and again and again. We'll just make it available. Okay, good. Right. Any question on the first one? We're doing 2.1.1. We're representing the real numbers. So real numbers represent the real numbers. Real numbers means X is an element of the set of real numbers. This is how we write the R for real numbers. Okay, it's not just a R, but we write it like this. This is like some script R, and we indicate that it is true such that X lies between 2 and 7 inclusive. What does inclusive mean? It means, therefore, that X here is equal to 2, X equals 7, but lies between them. So 2 is less or equal to X, and X is less or equal to 7. And this is called the set builder notation. Set builder.
Before we continue, can I ask?
Yes, please.
I'm gonna sit home and practice. Am I allowed to come back to you maybe and show you how far and
yes you can give feedback. You can share your journey, your learning journey, because that is what is going to make the learning effective. Okay, because once again, learning becomes effective when we do. Learning is a sport. You know, it's a sport, because if you become a soccer player who sits on the bench and does not get on the pitch to kick the ball, will often never be able to play soccer that way. Because there are many people who watch Orlando Pirates at home. But if you can put them on the pitch, on the field of play, they comment that, this guy is a cow. You know, they can say this player is a cow. This player can't kick the ball. He's not able to. They can comment because they can see. But if you put them there and you say start, they know what the styles are. They know seeing them, but doing them is something else. They don't practice. So the one who practices.
They don't.
Yeah, my point is, therefore, practice makes perfect. Practice makes perfect. Thank you. Let's move to the next question. 2.1.2 is represent the real numbers from 2 to 7 inclusive, sketched on a number line. Here's a number line. These are the real numbers. We call them X. And we have the numbers from 2 to 7. We put the small one first and the big one last. And inclusive. And then what we do is we do this. We do this, and this is what we have. But again, I mean, there are many ways. You can say 0, 1, 2, 3, 4, 5, 6, 7, 8. So that from 2 to 7. And then you do this. Right. So, and obviously you have sketched these on the number line. Now, any question, any suggestion, maybe you're looking at these and like, okay, but can we do it this way? Can we do this? Okay, yeah, but you see, I've seen like the interesting stuff, 2 to 7. Sometimes you can do it like this, but this is it's a bit too much. You can shade here like this, and make the line thicker here.
Yes.
You can make it thicker here like this. And then, so you can do it like this, but now making it thicker finishes a lot of ink, I think. Okay,
yes.
Writing in school, it finishes ink. Now you are writing or pencil. You are shading here or between the 2 and the 7. Nobody just write in the top. You draw the line once, But
okay, yeah.
This is also a correct what? It's also a correct notation.
Okay, so they are both the correct notation.
Yes, they're both correct. Both correct notations. Okay.
Okay.
Right, that's awesome. Let's look at the next one. If you look at 2.1.3, okay, this is called the number line. We call this the number line. Right, so now this is extremely important because there are different ways of showing sets. This is called a number line. It's called a number line. Then the next thing is the interval notation. What is the interval notation? How does the interval notation look like? Okay. Remember, these things are not from me. They are from the material for this course,
Yes,
They're not,
yes.
Yes. Like these questions I'm doing now, these ones I took them from a past exam paper. These ones.
Okay.
Yeah, I took them from a past exam paper that was written in January this year.
This year.
There's a paper that was written in January this year. So I took some of the questions from that paper. So this was the whole question 2. I just picked it from the paper as it is. And this whole question 2 was out of 36 marks. The total is at the bottom there. Okay, it was out of 36 marks. So I decided, let us do the question 2, and then we're mixing the assignments with the past exams, we're doing everything just to make sure that we get to know the kinds of questions they bring in the exam and also in the assignments, but also that we're able to do the questions or to solve the questions. The interval notation. Interval notation means that you have X is an element of the interval. What is the interval? Right, so the interval would be like this. You put 2, and then you put 7, like this.
All right.
This is called the interval notation.
All right, yes.
It's called the interval notation. It's called these the interval. Right, we call these the interval notation. We call these the interval notation.
So the X, it doesn't have to be inside the interval. It's outside.
Yeah, definitely. The X is surely outside the interval.
Okay.
The X is surely outside the interval. One way you can say X is an element of R, X is an element of this interval, and X is an element of the real numbers. No,
The
you
real
can.
numbers.
Yes. So X is an element of the closed interval, because the fact that it's inclusive means the brackets are square.
Yes.
Okay, so the brackets are square, because you can also write like this. And then now this is exclusive. Okay, because if you just write like this, X is an element of 2 to 7, like this. Then this is exclusive. Okay, this one would be exclusive, but this one is inclusive. Okay, this one is inclusive here. Now, there are a couple of things that you need to do as well. So if you look at this very carefully, this exclusive one, can also be written like this. In some other countries, especially it depends on in some other books. Okay, so normally in the caps it's not very popular, but now in particular, yeah, in the caps they don't include that. But now in mathematics in general, so this one would mean exclusive. So when the parentheses are round,
Yes.
you can actually write as a pair of parentheses that are facing the other directions, facing opposite directions. So round parentheses or round brackets are the same as square brackets facing opposite directions.
Okay.
You get the point?
Yes. So you can either use the parentheses or the square brackets that are looking the other way.
The other way.
Okay.
Yeah, but I know
Yes.
that if the ones that are looking the other way are not very popular in the curriculum.
They are not. Yes,
yeah,
they are not.
but in mathematics they're used. Okay, because I came across them when I was reading literature at university and so on. But doesn't mean they're for university. They are for the interval notation, but it depends on which one is taught. You know?
Yeah, yes.
Depends on who teaches. But the round ones are very popular. But these square ones facing the other way are very, very unpopular. But anyway, we continue to solve more problems. We do more number crunching as follows.
Okay.
Yeah, the next question is this one of the what you call the inequality.
Yes.
Given the inequality equation, this one, okay, normally this is called an inequality. Yeah, okay. So it is an inequality like this. Solve the inequality equation. We need to solve it. How do we solve this one? How do we solve this? To solve inequalities, we go to the basics of mathematics, but the fundamentals of all mathematical reasoning. And we then say that if you have twice x minus 3 all over 2 is greater or equal to 3x plus 1. You cross multiply like this.
Yes.
Multiply like this. Okay, now sometimes we don't want to use the word cross multiply here because the inequality is a very sensitive mathematical symbol. And so, because of its sensitivity, we take the LCD, the denominator, the lowest common denominator, and we multiply the left by the denominator, but we also multiply the right by the denominator. Maybe I can use a point, right? I can use a dot for the multiplication because there's x as well. So if I use a cross for the multiplication, it is potentially confusing. Yes, because somebody can think the cross that we intend to use for multiplication is an x. You know. So if I use a point like this, a dot, right? So we multiply by 2 both sides. Multiplying by 2 both sides of the inequality does not change the direction of the inequality. But what is then important is that these 2 is going to cancel that, and twice x minus 3 is greater or equal to 2 by 3. It's 6. X plus 2, like this.
Okay.
Then, which is twice x minus 3 is greater or equal to, what is 6 by x? We have exactly x plus 6 times 2. It's 12. Okay, now what we do is we collect like terms. We collect like terms. Right, we put the x's on one side and we put non-x terms. So there's 2x, we bring the 6x to this side and we have 12 plus 3, like so.
Okay.
What is 2x minus 6x? It is minus 4x. It's negative 4x, which is greater or equal to 12 plus 3 is what?
15.
Exactly 15. Thank you so much. Giving us minus 4x is greater or equal to 15. Like so. Okay.
Okay.
We then have minus 4x. We divide by minus 4. we have 15, we divide by -4. Right, so we divide by -4 like this. But when you divide by a negative number, the inequality changes direction. Okay, because it was a greater than symbol, now it's going to become a less than symbol.
A less than. Yes.
Like so. At this point, we're able to see, therefore, that we have x is less or equal to minus 15 out of 4.
15 over 4. Yes.
And therefore, this means that x is less or equal. What is minus 15 out of 4? It's minus. 4 goes how many times into 15?
It goes
3 times.
4 times. Sorry, yes. And then it lists out numbers.
It leaves a remainder. So 4 goes into 15, it divides 12. It goes 3 times into 12, and then the remainder 3 out of 4.
Yeah.
Okay, this is called a mixed fraction. It's called a fraction. What is a mixed fraction? Right, a mixed fraction is this one that mixes an integer.
A whole number and a fraction.
Yes, with a common fraction.
Yes.
So you have the -3 with the common fraction 3 over 4 is therefore called a mixed fraction. But we can be able to convert the mixed fraction back to what we call the improper. What we call the improper fraction. Right, how do we convert this one to this one?
Okay.
Right, we multiply 3 times 4. 3 times 4 gives us 12. 12 plus 3. What is 12 plus 3? It's 15 out of 4. Okay, so we've been able to convert the improper, this mixed fraction back to what we call an improper fraction. What is an improper fraction? We're discussing 2 kinds of fractions. There are fractions we call improper. There are fractions we call proper. What is a proper fraction? And what is an improper fraction? What is the difference between the two? Proper. Okay, there's something called a proper fraction. What is a proper fraction? A fraction is called proper. Yes. What do you think a fraction proper is?
It has only a numerator and a denominator.
Yes. Yes, it has a numerator and denominator. But most importantly, a proper fraction would have the numerator is smaller than the denominator. Then it's called proper. Like if this one is 3, then the bottom is 4. The bottom is always bigger. And if it's always bigger, then it's called proper.
Yes.
Improper would be like -15 over 4, because 15 is bigger than 4. And therefore, if the numerator is bigger than the denominator, then the fraction is called improper. Improper. Okay, we continue to the next problem.
Yes.
2.2. 2.2. Illustrate the solution on the number line. What is the solution to this? The solution we got is actually x is less or equal to -15 out of 4. We got here x is less or equal to -15 out of 4. And now we were able to analyze that this is exactly the same as x is less or equal to -3 out of 4. Right, and you can even be able to say this is -3.75, so that you can be able to position your things very well. But it doesn't really matter. You can just be able to put -15 out of 4 here, and x is less or equal to. So what you do is you take this. You take this.
Okay.
So now this, because illustrate the solution on the number line, this is the illustration. So you plot minus 15/4 and you go x is less. You go to the left of it. So you go to the left of it.
Okay.
So you go to the left of 15/4 of minus 15/4 because x is less. So you go to the left of this. So any question or any remark, any contribution there on this one?
Nothing so far.
Nothing so far. Okay, we're good. We're good. We continue right now to try the next problem. This was in January. January, that the students had to jostle with this one. They had to fight with the questions here. And some succeeded, but some couldn't. So we are practicing everything so that we can get to understand what the course expects. We are doing the best we can. That the student who, the student who tries is the one who tends to succeed, because we say try and fail, but never fail to try. This yes, you need to try. Doesn't matter how difficult. You're running Comrades Marathon. Try, go there and run. Okay, now you are running there, you realize you are tired, you need to go and train more. You train more, and that is what it takes to succeed, because you can't just get on the Comrades Marathon and just become #1 without practicing, You need to practice. You need to go on a diet. You need to slim. You need to do everything you can. You can't be too fat to run the marathon, for example. Most of the marathon winners are not very obese people. Most of them are very skinny. I watched many of the marathon winners. They are very skinny, and they made it in the Comrades. But the obese ones who are eating cakes every day, they're at home. Hey, my goodness. Sometimes you find that they can't even run. They can't even reach the finish line. They give up on the way, Okay, yeah, right. We continue. Now, this one is saying we need to solve these equations. We need to solve this equation. So if you have 2.3.1, let's solve this equation here. Right, to solve this equation, we square this. To square these expressions are called binomials. What is a binomial? Right, there's something we call a binomial. Binomial expression. What is a binomial expression? A binomial expression is an expression of two terms. Bi means two. X plus Y is called a binomial. Okay, there's a certain expression we call a trinomial. What is a trinomial?
I think it's gonna be your three expression.
Three-term expression. Yes, three-term expression, like x plus y plus z. It's called a trinomial. So they're like three terms. Popular trinomials are in standard form, and we have ax squared plus bx plus c. It's called the standard form. And this one here is a quadratic, right? It's called a quadratic trinomial. A quadratic trinomial. Okay, let's come back to this. We need to solve. We need to solve this one. The students were given this one in January and they jostle with it. Let's look at this. How do you solve this? Now, there are many ways to solve this one. Tons of ways.
Yeah.
And for me, I can just say, is there a common factor here? Yes. Then factorize. Take out the common factor. So you have x plus 1 squared. You bring this one across. You have x plus 1.
Yes.
2x plus 3 equals 0. You have x plus 1. You pull it out, the x plus 1.
Yes.
Right, because there's x plus 1 here and x plus 1 there. But if you pull it out, then what you're going to have is this one is going to disappear. Here we're going to remove 1 and be left with 1. In which case, therefore, we shall be left with x plus 1 minus, then we have 2x plus 3. Like this. You get the point?
Okay.
So this is what we get. We have x plus 1 like this, and then we have minus, open bracket, 2x plus 3. So this is what we can do. the x plus 1 outside the square parenthesis. With x plus 1 here, we distribute. By distribution, we get minus 2x minus 3, close bracket, equals naught. X plus 1, what is x minus 2x? Minus x. What is 1 minus 3? It's minus 2.
Negative. Yes. So, okay, can I stop you?
Yes.
Can I stop you for a second?
Yes.
On just above where you started by x plus 1, where you raised the x plus 1, is it because they are similar?
Yeah, that's because they're similar. So we take out a common factor. So when you take out the x plus 1 is a common factor, if we remove there's x plus 1 here, but if we remove it, then it's going to disappear from this place. In which case, we're then left with the 2x plus 3. That is the 2x plus 3 that is brought down here. But because this x plus 1 and that are similar, are the same, in fact.
Yes.
Because they're the same, then we take out the common factor.
The common factor.
And this method of factorization is called the method of factorization of what we call the highest common factor, HCF. Now, the highest common factor means that we are taking out the highest factor that is also common. At this point, the common factor, because this is 2x plus 3, but there's not this one. This one does not have 2x plus 3. What we can see, we can see x plus 1 here, but here we are seeing x plus 1 all squared.
Yes.
And then now we can see, x plus 1 is the highest common factor. So it becomes what we call the highest common. It becomes the highest common factor. Right, in which case, therefore, we pull it out, the x plus 1. Here we cross it out because it's similar, it's the same factor, so we cross it out. So we're going to be left with only 2x plus 3. Here there are 2 of x plus 1 because it's 2x plus 1, it's x plus 1 all squared. So because there are two factors of x plus 1, we take one factor out, and we have x plus 1 squared. Then we have x plus 1 squared. Okay. Right. Upon then careful examination, we get the following. So we then say the x plus 1 has been factored out here, and here there was a square. So if you remove one of the factors from the square, then you're left with power 1. Power 1, we don't normally write it. Okay, we don't normally write power 1 because the power 1 does not change anything. Okay, so we have x plus 1 here, x plus 1 here, and minus 2x minus 3. We have x minus 2x minus x. What is 1 minus 3? It's minus 2.
Yes.
Which means, therefore, we have here x plus 1 equals 0, or minus x minus 2 equals 0, which means x minus 1, or x equals what? Or x equals minus 2.
Yes.
Okay, let's do this one properly. We can do a little bit more steps here. Because here we have minus x minus 2 equals 0, which is minus x equals 2. You divide by minus 1, which means x equals minus 2.
Okay.
X equals minus 2. So that becomes the answer.
Okay.
Right, so this becomes the answer. But there are many ways to do this question.
Yes.
There are many ways to do the question because you can find other ways to do it. Another student can come up and say, okay, but I can do it differently. Another student can say, okay, we got the answers, x equal to minus 1 or x equals minus 2. X equals minus 1 or x equals minus 2. But another student can come and say, hello, this is just, there's another way to do this, because if you have x plus 1 squared, I know the students are very creative, and you have x plus 1, they're going to watch this video, and you're going to watch this video, you might come up with a different idea. Somebody can say, we can just square, why don't we just square this one? And why don't we just open up the brackets here? Because we can multiply here using the fold method. We can multiply this with that. We can multiply this with this. We can multiply this with this. We can multiply this with this. Why don't we do that? Okay, I mean, that is correct as well. That's just like another way to do it. So if you have the x plus 1 all squared, you square this becomes x squared. X by 1 by 2, it becomes exactly 2x. Right, so you get here exactly 2x. Right, you get here exactly 2x, you square the 1. What is x by 2x? 2x squared. X by 3x, 3x. 1 by 2x, 2x. 1 by 3, it is 3. Okay, now to square this perfect square, to square perfect square, we say x, we square. We square the x, and then we get x squared. Next, we say x times 1 times 2. X times 1 is x, times 2 is 2x. We square 1, right? And then we have x times 2x, which is 2x squared. And then x, because we multiply this with that. And then we multiply x times 3. What is x times 3? It's 3x. Then multiply 1 times 2x. It's 2x. 1 times 3, it's exactly 3, giving us this. And this is therefore x squared plus twice x plus 1 equals twice x squared plus, what is 3x plus 2x? It's exactly 5x plus 3. So, okay, we collect like terms. Right, collecting like terms, we can move everything across. We have x squared, we transpose this one. 2x, we transpose this one. 1, we transpose that. What is x squared minus 2x squared? It is exactly minus x squared. What is 2x minus 5x? It's exactly minus 3x. 1 minus 3 is what? It's a minus 2 equals -2.
Yes.
Now what we do
I
is
think this one is the one I'm going to practice with.
I think so. It might be easier than the first one we used.
Yes.
It might be a little bit easier than the first method we used. Okay, so at this point, yeah, I believe as well. So now at this point, we need to solve for x. And to solve for x given a quadratic, we need to make the coefficient of the x squared term positive. It's easier. Okay, so now we can decide to divide by -1. So we divide this one by -1. We divide by -1. We divide by -1. Alternatively, what we do is because we want to change this sign here, we multiply by -1. But in mathematics, whatever you do on the left must be done on the what?
On the right as well.
On the right. So you multiply by -1 on the left, but also on the right. So this is exactly x squared plus 3x plus 2 equals -1 times 0 is 0. Okay, by multiplying by negative, you make sure that this x squared now has a positive coefficient. So we have exactly x squared plus 3x plus 2 equals what? Equals 0.
Yes.
Right, the factors of these here are as follows. So you have the factors of x squared, which are x and x. Factors of 2 are 2 and 1. And you put plus and plus. Which means at this point, x is -2 or x is -1.
1.
Yes. So those are the answers. Because before we got x, let's check what we got. We got x equals -1 or x equals -2. Now, in this case, that is the first method. Let us check the second method. The second method, we still got x equal to -1 or x equal to -2 or x equal to -1. So the solutions are the same. Okay, the solutions are the same. So obviously, it is a demonstration of the consistency of mathematics, right? The mathematics itself is consistent. It doesn't matter the method you use. By and large, we always get the same result. We always get the same answer to the questions. We solve the next problem. The next problem we're going to solve right now is 2.3.2. We have a minus 7. A plus 3 equals 24. Right, so now we need to solve this one. To solve this one, you can do the same. You can multiply this one with this one, this one with this one, this one with this one, and this one with that. Okay, this method of multiplication has a special name in mathematics. So if you multiply A by A, these are said to be the first. A by A, they're the first. A by 3, they're outers. So those are the first. These ones are called outers. These are called inners. These are called the last. Okay? So this method is called the FOIL. It's called the FOIL method. It's called the FOIL method. So you multiply A by A, you get what? You get A squared. The first, they multiply A times 3. A times 3, A times 3, which becomes exactly 3A, minus 7 times A, minus 7A, minus 7 times 3, minus 21 is exactly that, which is X squared minus 4A. And then now you have minus 45 equals 0. Okay, we brought the 24 to the other side, it became negative. So if you have minus 21 minus 24, you get minus 45.
Yes.
Okay, so now there are two. Now, what are the factors of A squared? Factors of A squared are A and A. Okay, we're dealing with the factorization now. The factors of A squared are A and A. We will spend more time on the factorization at some point, just to make sure that we build the skills and we develop the mathematical skills and mathematical acumen. Okay, that is very important. Right, so the factors of A squared are A and A. There are two numbers whose product is minus 45, but whose summation is minus 4. What are those numbers? Think about this. There are two numbers whose product is minus 45, but whose summation is minus 4. What are those particular numbers? What are those particular numbers? So you think about this. You think seriously about this. And those numbers are what? Are actually minus 9 and plus 5. Because 9 times 5 is a 45. But if you add them, minus 9 plus 5 is minus 4. So these therefore are the correct factors. I'm yet to spend more time on factorization, please.
Okay.
Spend more time on factorization so that you can be able to factorize a wide range of problems, because sometimes they bring tricky questions here. Okay, there are some
so basically, when you get to this step, you should look at factors like
the factors of
9 minus 4. Does
9,
it give
yes.
us, I mean, 9
yes, yeah,
minus 5, it gives us 4. And then if it doesn't, you continue with another
continue
step.
and try other factors. Because now here you come, if you have minus, you add this, you add minus 9 and 5. Minus 9 and 5, if you add them up, you get minus 4. So they give us this middle term. But also, if you multiply them, minus 9 times 5, you get what? Minus 45, and therefore that becomes a result. But again, I mean, this is the shortcut. What the kids are being taught at the moment, it's the actual correct way of factorizing, which wasn't taught in the South African schools ever since. It is now in the new CAPS curriculum that the kids are taught the following method of factorization. Through an investigation, I've seen the kids, because I tutor the kids, you know, so sometimes they come with these investigations, and I get to see across provinces, in Limpopo, in KZN, in the Gauteng province, in Mpumalanga, in the Northern Cape, in the Western Cape, the Eastern Cape, I've received, you know, tasks and projects from those kids. And the popular narrative was, okay, they are being taught that to factorize this, you need to, which is the correct way of thinking. The British kids were taught this for ever since I've known the British system. So, and to factorize a quadratic, you multiply the first and the last. That's what you do.
Okay.
Multiply the first and the last. And if you multiply the first and the last, what then do you get? So you multiply a squared and minus 45, which is minus 45, like this. Minus 45 a squared.
Okay.
Okay, so you multiply the a squared and the what? You multiply the a squared and the minus 45.
Then
Okay,
negative 45, yeah.
and you get minus 45 a squared. And then you factorize this minus 45 a squared. You look for the factors of this, which will produce the middle term, which will yield the middle term. And you look for the factors of minus 45, that will bring minus 4. And those factors are minus 9a
Yes.
and 5a. Okay, you can just think of the minus 45. What two numbers do you multiply to get 45? That when you subtract would give minus 4. Those numbers are 9 times 5 gives 45. Okay,
Yes.
but now at this point, because it's minus 45, then you need to say minus 9. One of them must be negative, because when you multiply them, you must get a negative. But also when you add them up, you need to get minus 4a.
Okay.
So therefore, the bigger number must have a negative, so that when you add them up, you get a negative number here. So that now, okay, I'm going to use the British way to do this. So you have a squared now, you have minus 9a, and you have the 5a, which is minus 9a plus 5a. Okay, minus 9a plus 5a will give minus 4a. Minus 45 equals 0.
Yes.
Factor out a, and then you have a minus 9 plus, you factor out 5 here, which is a minus 9 equals 0, which means a minus 9, a plus 5 equals 0, which means therefore you have a equals 9 or a equals minus 5. Okay, so this will sort of become the answers. This step is tricky to many kids, many students. They don't understand this method. But, okay, at this point, you take out the highest common factor of the first two terms, because there's a squared and 9a. But when you factor out the a here, you cross it out here. And then you factor out the a, because there's a squared, you factor out a, and then you left the power 1, so that we have a to the power 1, and then here left only minus 9. Here you take out the common factor, which is 5. So if you take out the common factor, which is 5, here you're going to have only a, because the 5 is taken out. If you take out the common factor from minus 45, it's like you divide minus 45 by 5. If you say minus 45 divided by 5, what do you get? You get a 9. You divide this one, you get a 9. Okay, you divide the 45, because if you factor out the common factor 5, you divide 45 by 5, you get a 9, which is negative. So you have a minus 9, a minus 9. And then now you take out a minus 9 as a common factor, and then you'll be left with a plus 5 equals 0, which means a equals 9, a equals minus 5. So that is the answer to this problem. Okay, yeah, that is the answer to this problem. So think about it. As I said, right, this lesson is recorded for control and quality purposes. You'll have a chance to watch it, replay, and play again. Okay, yeah. So until you understand. But I'm going to gather more problems, practice problems for you to learn more of these things. But like practice problems that are more repetitive. Okay, they are those practice problems for mastery purposes. Okay, now we continue to look at 2.4. In 2.4, we're speaking about Lindo. Lindo purchase is a story sum. Let's look at the story problem. In January this year, the students for this course were given a story sum. Okay, we call it a word problem in mathematics. Lindo purchased 12 meters of a curtain material, some of which had a slight flaw, and was priced at 21 Rand per meter. Instead of 24 Rand per meter, Lindo paid a total of 280 Rand and 50 cents for the material. Determine how many meters of flawed material Lindo bought for 8 marks. Okay, this is the story problem. It's a word problem. They've given you words, and you need to solve this and determine how many meters of flowed material Lindo bought. Okay, to do this question very carefully, there are two things here.
Yes.
Lindo bought this curtain. Okay, maybe Lindo has a house. They want to put a curtain there in the house. But the problem with this curtain Lindo bought, some of it is damaged. It has a slight flaw. Maybe it's torn. It's torn in some parts, and was priced at less than because the normal price per meter is 24 Rand per meter for the curtain. So if Linda buys this curtain, then Linda is going to pay 24 Rand per meter. But the guy who is selling the shop, he said that, okay, Lindo, because you can see that this curtain is damaged here, so you go to the manager of the store and you say, manager, it's damaged here. I want it. I like it, but it's damaged. So maybe can you offer a discount or something? So this manager says, okay, now the part that is a slight flaw, that is damaged, is going to be sold at 21 Rand per meter.
Yes.
And then determine how many meters of flawed material Lindo bought. So now, what do we do here? What do we do in this particular case? So to solve this problem, we let, because it's a story, this one, but we need to solve it. So we let X be equal to, because we let X be what we want. What do we want?
Yes.
Want to determine, we let X to be the unknown. Right. So if we let X to be the unknown, we're dealing with the unknown. Okay, dealing with the unknown, we let X be the unknown. What is the unknown? Determine how many meters of flawed material Lindo bought. We need to know how many meters of the damaged curtain Linda bought. And then some of the curtain was okay, but some of it was not okay. All right, so we let X be the number of meters of flawed material. So let X be equal to the number, right? Let X be the number of meters. Right, so let X be the number of meters, in particular, number of meters of flawed material. Okay, because some of the curtain was not okay, of flawed material. Okay, now let us solve this problem. This is what the students need to wrestle with here. Some of these questions are a little bit tricky, so you need to get ready for war here. Okay, this is the situation. So X is the number of meters of flawed material. If this is true, then what then do we say? Then what is the total number of these the curtain? Little pages 12 meters of material. But now 12 meters. Okay. Now, how much did everything cost here? Linda, a total of 280. Yes. Good.
50.
Good. So if you let X be the number of meters of flawed material, simultaneously you can let Y be the number of meters of right.
You're breaking.
Okay, I'm breaking. Okay. I'm so sorry that I'm breaking.
Fine. You said it's recorded, right?
Yes. If I happen to break, then because the network can fail, but the recording is always going to be perfect.
All right.
Recording will be perfect. I know that I can be breaking sometimes. I don't know because it's the network, but I cannot know if I'm breaking myself. So will X be the number? I know this is a very important problem. Right. So you let X be the number of meters of flowed material. Let Y be equal to the number of meters of the perfect curtain. Right. We're gonna call this one the perfect curtain that has no flaws. So let Y be the number of meters of the ketane with no flaws.
Yes.
With no flaws. Okay. So what is the total number of the meters that Linda bought? Linda bought 12 meters.
12.
So it means
Yes.
the X, which is flawed,
Yes.
the bad one, and the good one, which is okay. Number of meters of
Yes.
ketane with no flaws is Y. If you add the bad and the good ketane, everything is 12
You
meters.
get a 12.
Everything
Yes.
is 12 meters because the ketane is divided into parts that are good, no flaws,
Mm.
and parts that have flaws. So you break it into the two parts and then say X is for the part that is flaws and Y is for the part that is no flaws.
Yes.
Okay. Now,
okay.
The total, it's 12. Once again, this is recorded because I know the network breaks, but also to keep records. You can watch this as you want. This video is going to stay on, it's going to stay available. It's going to remain available. Okay, so yeah, no stress. But Linda purchased 12 meters of ketane material. The damaged part and the part that was okay, if you add everything, you get 12 because Linda purchased 12 meters of the ketane. Okay, but some of which had a slight flaw, and now now we have this here. We have this. Now there are a couple of ways to reason this out. What do we want? We want the flawed material. So we want to solve for X. We want to solve for X. Right, want to solve for X. So what do we then say here? We continue to then say, now, some of which had a slight flaw and was priced at 21 Rand per meter. The damaged one, the one that had a flaw, a damage, was sold at 21 Rand a meter. So now X has flaw, so it's 21X plus Y instead of 24 Rand per meter. So the one that is okay, the standard price is 24 Rand per meter.
24 Rand, yes.
Yeah, so which means that you'll take 24 and multiply Y by 24.
Yes.
Because Y is the ketane with no flaws. And then what is the total of everything? Lindo paid a total of 28 Rand or 280 Rand and 50 cents for the material. So if you add the money for the bad ketane, the one with flaws, the one with no flaws, everything is 280 Rand and 50 cents. That is it. So now these things, we call them simultaneous equations. So the minute you have what you call simultaneous equations, you need to solve them simultaneously. Right, simultaneous equations. Simultaneous equations. So we need to solve these simultaneously. How do you solve this simultaneously? We want to get how many meters of the flowed material. So want to solve for X. So let us use some different color. All right, even if I'm breaking, you're gonna get a perfect sound, please. Forgive me for that. Network, South Africa. I know, this world is still improving. We'll be having the best network very soon in the world. Yes, yeah, that's a good question in terms of when. But you see, the world is improving because you see, where I'm broadcasting from myself, I'm broadcasting on Wi-Fi. I use Wi-Fi, but this Wi-Fi is fiber Wi-Fi. So the belief is that fiber Wi-Fi is better than just Wi-Fi I can get from Vodacom, normal one, or anything from MTN. That is the belief. So it is an improvement in the technology space. Okay, now we solve for Y here. Y is equal to minus X plus 12.
Yes.
Okay. Call this one equation 1. And this one, you call it equation what? Equation 2. So now you're going to continue and say put 1 into 2. Put this equation into this one.
Yes.
So that now you come here and then say, you have 21x plus 24. What is y? Y is minus x plus 12.
Yes.
Minus x plus 12. We are in this equation, which is 280 and 50 cents. Okay, even if I'm breaking, please, I mean, the recording is always perfect by and large. Okay, yeah, you can be able to hear me very well. So we have 21x plus, okay, so there's a minus here. There's a minus here. So you have 21x minus 24x. Okay, and then there is now we need to perform further distribution. Right, so we need to perform further distribution. Just to check, I can use my calculator to just perform some of these to make sure we get the correct answers. Right, so to get correct answers, I'm going to use my calculator for some of these things. I think I launched a calculator. I placed it here. Here is our calculator, and we're just going to use it. I want to use the calculator to multiply 24 times 12. What is 24 times 12? 24 times 12. What is 24 times 12? It's 288.
Yes.
Good. It's 288. So you're going to come here before and right here and then say, so this is going to be exactly plus 288, which equals 280.50.
Okay.
What is 21x minus 24x? What is 21x minus 24x? What's the answer?
It's -3.
-3. Well done. -3x. And then we can move this one to the other side. So now we have 280. 280 and 50 cents. We subtract 288. Okay, we collect like terms and we just put these constants. We call them constant numbers with no variables in them. So we right, so we're gonna have this. $280.5 minus 288 minus 7.5.
Yes.
Minus 7.5. So which means it is minus 3x.
Yes.
It's minus 7.5. And then we must solve for x here. Right, so to solve for x, which means x is minus 7.5 divided by minus 3. Which means x is equal to what? Let us check with the calculator here. Let's do the division. So now, if we get to this point, we're saying minus 7.5 divided by minus 3. Right, so we're going to do this and say minus 7.5 divided by minus 3, which is minus 2.5. Minus 2.5. Minus 2.5. So that is exactly the answer. So anyway, it's plus 2.5, excuse. Okay, because we're dividing a negative by negative. So it's plus. Okay, right. We're dividing a negative by negative, and then we're getting a plus. Okay. Now, pay particular attention to what is happening here. What we are able to see is the fact that we got that x is 2.5. Right. So we're getting obviously to get how many meters of flowed material. So we had 2.5 meters of flowed material.
Yes.
Right, so this means that at this point we have x All right, at this point we got actually X equals 2,5 meters,
Meter.
right, of flawed material. Okay, so the type of material that is bad. Okay.
Okay.
We need to check if this answer is correct. Okay, we need to check because sometimes after doing a long calculation like this, there's always the chance of human error. You can make mistakes there. So we need to check this. We need to get Y also. Right, so how would you get Y? Right, you can get Y as follows. For example, you know that Y is equal to what? Y is minus X plus 12.
Yes.
So the X is 2.5. So this is minus 2.5 plus 12. What is minus 2.5 plus 12? Let's take a look. Let's take a look. Okay, now you're going to say 12 minus 2.5. Even if I'm breaking, please, you get it. Yes.
9.5, yes.
5. Well done. So 9.5. So you're going to write that one here. 9.5.
Yes.
So the 9.5 is good. It's the good cation. Okay, it's the good cation. If these answers are correct, if we agree that X is 2.5, or if we agree together the fact that X is 2.5 eons, you can write here.
Yes.
Right, if we agree that X is 2.5 meters and Y is 9.5 meters. Okay, if we agree that this is correct, when we add X and Y, we must get what? 12.
12 meters.
12
yes.
meters. Then that would mean the values are correct. But also, it would mean that if you put the X and the Y in the bottom equation, you will be able to get the correct answer. So we can, we're going to test. We're going to test with the calculator to be 100% sure that we're getting the correct answers. So it's X plus Y. So what is that? What is X? It's 2.5.
Yes.
2.5 plus. So you have 2.5 plus 9.5.
9.5, yeah.
And this is actually equal to 12. And Y must be 12. So this equation is satisfied. This equation holds. It's true. Okay, so the X, 2.5. And the Y, 24 by Y, which is 9.5.
Yes.
Okay, now you put the X here, which is 2.5.
Okay.
The Y, which is 9.5, but you multiply by 24. The answer must be exactly 280 Rand and cents. If these X and Y are correct. Okay, we are using this calculator to check. Exactly. So we're getting 280 Rand and 50 cents. It therefore means that these answers are correct. As a consequence, we conclude that indeed the damage, the flawed material that Lindo bought was 2.5 meters.
Yes.
2.5 meters. And then the 9.5 meters was good cation, perfect cation, no flaws, nothing. Okay, so we can see that indeed the flawed cation was shorter. It was only 2.5 meters that was damaged, that had flaws in it, but the perfect one that was so good was 9.5 meters of excellent cation.
Yes.
We have solved this problem. And this problem is the kind, so we'll do more problems like this, where you are given a story and you are asked to solve the story. They love these questions. But the students sometimes are thrown off. And the students sometimes find themselves in serious jeopardy because
Yes, because I've noticed they have too many marks.
they have too many marks. Because you see, this one is like
Yes,
8 marks. It's a
yes, 8
lot.
marks.
It's a lot. And if you
Yes,
get these 8 marks, you've already passed the course. You've already passed the course.
yes,
Okay, we continue to the next question.
yes.
Right, we continue to the next problem. Right, let us move to the next story. Okay, the next story is about Mrs. Taba. Mrs. Taba owns parrots, cats, and dogs, all of which live in her home. So Mrs. Taba loves birds and loves parrots.
Yes,
Parrots, cats, and dogs, all of which live in her home. The number of
yes.
dogs living in her home is twice the number of parrots, while the number
Okay.
of cats is one more than the number of parrots. When Mrs. Tupper looks at all her pets, she sees a total of 46 legs. Algebraically represent the number of dogs and cats in terms of the number of parrots for 5 marks. I've taken the opportunity today to spend time on factorization a little bit, but also on the word
Yes.
problem. So that we are able to solve these problems properly and in detail. But we build the mathematical argument to actually be in a position to solve these problems here. Right. So now, what then do we have, and how can we solve this particular problem? Okay, now you need to look at the first question. The first question says algebraically represent the number of dogs and cats in terms of the number of parrots. So now we will let x be the number of, because now
So,
you have the parrots, the cats, and the dogs. So you can say let x be equal to the number of parrots. Y be the number of cats.
yes.
And Z be the number of dogs. Okay, so this is it.
Mm.
So there are 3 types of animals here. We have parrots, which are the birds that talk like humans sometimes. They train they are very intelligent, these birds. You can send them to the shop to buy bread, and they'll bring the bread. You know, you send them, and they do things like humans. They are very intelligent. Okay, now Mrs. Topper therefore has, so if we say let x be the number of the parrots, y the number of cats, and z the number of dogs, and all of which live in her home. They live in Mrs. Topper's home.
Yes.
The number of dogs living in her home is twice the number of parrots. Let's look at what this means. What does this mean? If they say the number of dogs living in her home is twice the number of parrots, what does this mean?
It's
So
simply say, let's say for example, if
yes,
parrot, the number of dogs living, if we have 4 parrots, it means we're gonna have 8 dogs because it's twice the number of parrots.
well done.
Yes.
I agree with you on that.
Okay.
I agree with you on that.
Yes.
Okay, so, but now, well done. I love the way you expressed it.
Yes.
That is very, very brilliant. So now we need to express it in terms of an equation. So the dogs are Z. The dogs are Z. And
Yes.
the parrots are X.
Uh, Yes.
So we need to relate these two. We need to form an equation according to this sentence here. The fact that the number of dogs living in your home is twice the number of parrots. We need to write this properly.
Mm.
Okay, I said already, yeah, if you are breaking and all that, you get perfect recording. So please do not worry.
Yes.
Okay, right.
Okay.
So in the end, the number of dogs living in a home is twice the. So if the number of dogs is twice the number of parrots, it therefore means that the dogs are more. The dogs are more.
Yes.
So the parrots are less. And therefore we must put a 2 here. If we are to create an equation, because the dogs are many than the parrots, are more than the parrots, so we put a 2 here like this.
Yes.
We put a 2 here like this. We put a 2 here like this. Next, while the number of cats is 1 more than the number of parrots, let's look at the cats. Now, Y represents the cats. And the parrots, X. Like this. So what do? We want to convert this sentence that says the number of cats is 1 more than the number of parrots.
Yes.
So now if you compare, so now we need to write an equation here. So if the number of cats is 1 more than the number of parrots, it therefore means that the parrots are less, so that we need to add the number of the parrots.
Yes, yeah.
Okay, you think about this because this, you must be able to get this right. Okay,
Yes.
we are like, this is like the foundation of the reasoning. Next, next, when Mrs. Tarber looks at all her pets, she sees a total of 46 legs. Okay, we shall get to the legs.
Yes.
But algebraically, in the number of dogs and cats in terms of the number of parrots. Right, so at this point, we want to algebraically represent the number of dogs and cats.
Yes.
So now, if you need to represent the number of dogs are what? Are Z in this question.
Yes.
Cats are Y. In terms of the number of parrots, in terms of X. Right.
Yes.
So obviously at this point, we have some work to do. But what then do we do? Okay, so at this point then, to realize what the examiner wants us to do is to then answer this question here that says, algebraically represent the number of dogs and cats in terms of the number of parrots.
Yes.
So how would we do that? How would we do that? We think about it. Because we want to write a perfect answer to 1.1.1.
Yes, we do.
Yes, we want to write a perfect answer. And there are just too many ways to obviously write this answer. But key to that is when Mrs. Tauber looks at all her pets, because this 1.1.1, how many animals are included? It says the number of dogs and cats in terms of the number of parrots. So it's all the animals in one equation. The examiner says all the animals in one, the dogs, the cats, and parrots.
And then parrots, yes.
But this equation, it has only 2 animals, like 2 variables and therefore 2 animals. Here 2 variables and therefore 2 animals. The examiner is saying, I don't want these separate equations. I want one equation that's going to have the dogs, the cats, and the parrots all in one equation. So how do we get this one? So we need to combine everything here. We don't need a separate pieces like this. But
Yes.
use the legs. We're gonna use the legs because when Mrs. Taba looks at all all of them, so the parrots, the cats, and the dogs, she sees a total of 46 legs. And it therefore means that now let us start. If X is the number of the parrots, how many legs does a parrot have? How
It
many
has 2.
legs? It has 2. Right, well done.
Yes.
So now you will say each parrot is 2 times X.
Yes.
Each parrot is 2 times the number of the parrots. If we want to find the legs of all the parrots, we need to say each parrot is 2 and then times X plus. And then next, what more do we have?
Dog.
Yes, we have the dogs. Because now we have the dogs. The dogs, how many
Yes.
does the dog have?
And it has 4.
It has 4. So it's 4 times Z, 4 legs times Z. Right.
Yes.
So we
Yes.
continue. We continue.
Okay.
And then plus, okay, we dealt with X. X was the parrots,
Parrot.
dogs, and Y the cats. How many legs does a cat have? It has 4. So that's going to be exactly 4Y because the cat is Y. And all the legs, how many? When Miss Taba looks at all her pets, this is a total of 46 legs.
Yes.
So if you add all of them, you get 46. And therefore, you can divide through by the highest common factor. What is the highest common factor here? You can divide through by 2, which means you have X. If you divide 4 by 2, what you get? 2Z. 4 by 2, you get 2Y. 46 by 2, you get 23. Algebraic represent the number of dogs and cats in terms of the number of parrots.
Yes.
Right, so that in the end then now, here's the question. Now we have this one, let's just write it properly. So if you need to answer, we answer this one to say we need to algebraically represent the number of dogs and cats in terms of the number of parrots. So what does this mean? Okay, with this now, we need to make something the subject of the equation here.
Yes.
Right. So the parrots are what? Are X. The parrots are X. So we need to algebraically represent the number of dogs and cats in terms of the number of parrots. And therefore, it means that now we can actually be in a position to represent the dogs, and the dogs are what? Are Z, and the cats are Y in terms of the parrots X. So we need to write the Z and Y in terms of X. Right, in terms of X. Right, so obviously now there are a couple of ways we can do that. So this is exactly what we've got here. And we can just be in a position to make the Z and Y the subject of the equation such that we have the X on one side. Doesn't really matter what we do. So we can write 2, and here we have Z plus Y equals 23 minus X, like this. And at this point, we therefore have Z plus Y, we divide by 2, which means it is 23 minus X out of 2. Okay, this therefore means that we have represented the number of dogs, Z, and the cats. Why?
Yes.
In terms of x.
X.
In terms of x. So you can write like that, or you can write z plus y is 23 out of 2 minus x out of 2. So the number of the z and the y are in terms of x.
X.
Right, they are certainly in terms of x. Okay, now, this is one thing you can do, but also I need to mention that what the examiner wanted in the question 1.1.1, the examiner wanted the following answer. So we will write the answers a bit more accurately now. So the examiner wanted the following answers. So the answer to 1.1.1, the examiner would prefer a separate answer. We're going to say the number of the dogs. The dogs are at. So you could write z equals 2x. The examiner would expect that because the dogs are, z is the number of the dogs.
Yes.
In terms of the number of the parrots, x. And also here you have the number of the cats, which is y, which is also x plus 1 in terms of the number of the parrots.
Yes.
In terms of the number of the parrots. So obviously, looking at the question, you could actually write these separately like that. And therefore, the examiner would accept in particular, this would be the most accurate answer is written from the two pieces for the first part of the question.
Yes.
At this point, the number of the dogs is that it is in terms of the number of parrots. And now also the number of the cats is why it is in terms of the number of parrots, which is y equals that. So the second part of the question that says, write the algebraic expression to calculate the total number of the legs.
Yes.
Right. So the algebraic expression to calculate the total number of the legs, you can write it in many ways, but you can write it like that. So you can write 2x plus, you can even write like that, 2x plus 4.
Yes.
That. Okay. So yeah, you can write 2x plus 4z.
Yes.
Plus 4y equals 46. All right. In case therefore, yeah, you can leave your answer like this, or you can simplify it and write x. If you divide, we divide it here, and you got this one.
Yeah.
So you can write x plus 2z, 2y equals 23. You can divide through by 2. So you can write your answers like that. So this would be very, very sufficient to write to answer this question. So the 5 marks, what were the 5 marks for? The 5 marks were for just a separate equations.
Yes.
The number of the dogs in terms of number of parrots is 2x, and number of the cats in terms of number of parrots is x plus 1. Then the next one, right under the print, calculate the total number of the legs, which is exactly this one. You get the point? Which is exactly this. Then we do the next thing. We do the next. So yeah, how many cats does Mrs. Taba own? Please show all your work and explain your thinking. Let's look at that question. How many cats? Here's the question we're looking at now. How many cats? I want to carry this forward. So we know that Z is 2x.
Yes.
Z is 2x. Y is what? It's x plus 1. Okay, like this. And then now we think about this. And we note that the x represents the parrots. So that don't forget, y represents the what? The cats.
The number of cats, yes.
Okay, and z represents the what? Z, the
Number of
dogs.
dogs.
Yes,
Yes.
Z is the number of dogs. Okay, good. I just want to make sure we don't forget. Okay.
Yes.
So now we want to therefore here this one x plus 2, we can write x plus 2y plus 2z equals 23.
Yes.
Okay, we can write x plus 2y plus 2z equals 23. How many cats does Mrs. Staba own? Please show all your work and explain. How many marks? 8.
8 marks.
A lot of marks.
They are.
They are. Okay, yeah, I know this one is pretty straightforward because I've already done a lot of the groundwork. Because I've already done a lot of the groundwork, then we are able to answer this particular question. So what then do we do here? What then are we able to achieve here? Okay, I know this one you can do with your eyes closed because you're able to take a look and see what is happening. And now think about it and yeah, and obviously get a chance to sort of analyze it carefully. Okay, so what do we do right now? What do we do right now? What do we do right now? Okay, we do substitution to solve this simultaneously. These are like simultaneous equations. We need to put one equation to the other and, solve here. Right, so at this point, because of these equations, we want to find the number of the cats. How many cats? And the cats are y. So we need y. Okay.
Yes.
So if we need y, what does it mean? What does it mean? We can do
Are we
it.
going to take the
Yes.
2y? Are we going
Yes.
to take the 2y?
Yes. Yes,
Okay.
we can take the 2y, but we need the value of y.
Yes.
So, I mean, there are longer ways, there are shorter ways, but we can just manipulate these equations in a way that is going to give us a y.
Yes.
Okay, and anyway, what the examiner expected here was a little bit a long way around. Okay, this is sort of been the natural way to think about it, but we have the x, we have the y here. Is x plus 1. The z is 2x. It's 23. It's x plus 2x plus 2. 4x equals 23. We have x plus 2x plus 4x.
Yes.
Which is 7x equals 21. If 7x equals 21, divide by 7, and then you have x equals what? X equals 3. Once you get x equals 3, then we can use this particular equation to get y, because we want the number of the cats, how many cats, and the cats are y. So we have x plus 1, and then the x is 3 plus 1, and then it is exactly what? A 4.
4.
Yeah, so that is the answer. So at this point, it means that we have how many things? Obviously, it means that Mrs. Taba,
Yes.
right, Mrs. Taba has 4 cats. Has 4 cats. What is your... Yeah, so that is sort of the thing we have here. That is sort of the thing. Okay, so there are 4 cats. Any question, think about it and make sure you sort of understand what is happening here. So these are exactly the... Okay, but we're not done with the question.
Yes.
Because now that was like 1.1.3 that we've solved.
Yes.
So what is then the next question?
On 1.1.3.
Yes.
They said you should explain your thinking.
Yes, and explain your thinking.
Yes.
Right. So yeah, show all your work and explain your thinking. Okay, they're being funny there to explain your thinking because I mean, what kind of explanation is the algebra? You need to explain the algebra. So is substitution, that is the explanation of your thinking, first and foremost.
Yes.
So you
Yes.
need to perform substitutions like, you see, in principle, these equations need to be given names. Call this one equation 1, and call
Yes.
this one equation 2,
Mm.
and call this one equation 3. So you have like 1, 2, 3 equations. At this point, you need to say put or substitute. What did we do? We substituted 1 and 2 into 3. So put
Yes.
1 and 2 into what? Into 3. Okay, we took the 3, then we put the equation 1, the equation 2 into 3. That's what we did. This was equation 3, and we put the y, we put the z, and we got x, and then we got everything there. And then
Yes.
we got everything there. So any specific um um any specific question, think about it.
Okay.
Yeah. Okay, but
So
yeah, that is explanation of the thinking. Yeah.
the thinking is the substitute that we substituted equation 1, 2, and 3.
Yes.
So we should all put it like that.
Yes, that is sort of the explanation.
Okay.
There's not much you can explain. But
Yes.
just that
Because
they know
already
that,
you worked down on the equation,
yes, you already worked out the equation.
on the calculation. Yes, yes.
And the equations take a lot of effort and
And
strain.
they put out all the information out there.
Yes,
Uh,
most definitely.
Okay.
I agree with
Okay.
you. All right. So this
Mm.
is sort of really what happens here, and therefore it's something that obviously you need to understand.
Okay.
Something you need to sort of understand. Any question, any contributions, any suggestions before we move to 1.1.4?
Before we move to 1.4,
Yes.
here it says how many cats that she has. We found that
Yes.
she has 4 cats. And
Yes.
on the first explanation, it says the number of cats, it's plus 1 the number of the parrot, meaning our parrot are 3.
Yes, it means our parrots are 3. Yeah, that's correct. Yes, it means our parrots are 3.
Okay.
I like that logic. I mean, you really are on point there. That's correct reasoning. Yeah.
Yes, because it's gonna take us to 1.4 where we have to calculate number of legs after
Yeah.
she has bought 4 more dogs.
Okay, this is a funny question. Okay.
Yes,
Right. We're not dealing with too many animals here. Okay, now
yes,
let's deal with this one. So Mrs. Starmer now buys 4 more dogs. Calculate the total number of legs that she will see. How many legs will she see exactly right now?
okay,
Uh-huh. So in other words, you need to remember that this is X,
yes,
2Y, 2Z equals 23. Okay, that is sort of the
yes,
for the legs, for the number of legs.
yes,
Okay, that's
yes,
what we got. It was like X plus 2Y plus 2Z equals 23.
yes,
Right, so um what then? We substitute everything, but now we need to remember something, that
yes,
Mrs. Starber buys 4 more dogs. So it means that the new equation is going to be, okay, X is for parrots.
yes,
Y is the cats. Z is what? The dogs.
it's the dogs, yes,
The dogs.
yes.
So now, I mean, if you look at this question, then what are we effectively then saying here? So, but now if she buys what? 4 more dogs.
4 more dogs.
Yes, there is another there's a new equation that is gonna come. It's gonna arise from the fact that the dogs are now more.
Yes.
So initially the dogs were how many in this equation? The dogs were Z, but
Yes.
now they're gonna be 4 more dogs. Okay, because she buys 4 more dogs. So whenever
Yes.
we had the number of the dogs, which was Z, and then now they're gonna be
Yes.
6 plus 4. And
Yes.
therefore this is X plus 2Y plus distribute here 2Z plus 8. So X plus 2Y plus 2Z, which is 23 plus 8, which is exactly 31.
Yes.
Is it? Okay, we're checking here. Okay, because you're adding 4 dogs.
Yes.
All right, so yeah, you're adding the 4 dogs. What you got?
Oh my gosh.
Okay, yeah, but that is the thing, because now you had X plus 2Y plus 2 that equals 23. Now we added 4 more dogs. Okay, the dogs are Z. Z represents the dogs, which means that
Yes.
Z plus 4 for the dogs. Okay,
Yes.
but now you multiply it through by 2, you distribute here, which is X plus 2Y, and then 2Z plus 2 by 4, which is 8. So the X plus
Yes.
2Y plus 2Z. What is X plus 2Y plus 2Z? X plus 2Y plus 2Z is 23. Whoever was saying
23.
X plus 2Y plus 2Z, we put 23. But there's an 8 that has come there. And then now we say
Yes.
23 plus 8. And obviously, if you launch our calculator,
It's 31.
it's 31, no doubt, right? Right. So if you add 23 and 8, you get 31. So obviously it means therefore Mrs. Taba is gonna be seeing 31 legs. Calculate the total number of legs that you will see. So Mrs. Taba, which is Mrs. Taba.
So those legs are the legs for dog's legs only.
No, for all the animals.
No,
Because it's the
all the
total number
animals.
of the legs.
Yes. Okay.
Okay, but remember that you need to be very careful here.
Yes.
You need to be very careful. So you need to double this number. You need to double this number, because this is sort of the simplified answer. Because
Yes.
this one here, we simplified it already, but it was what? This one, we simplified it already. But initially it was 2x plus, because it had 2x plus 4.
Oh, it was not inclusive of all the animals' legs.
Yes, yeah, it was not inclusive
That
of,
is why it
because we
got
simply, yeah,
okay.
because it was 46 legs in the beginning. Okay.
Yes,
It was
yes.
46 legs. So we simplified it. You need to just remember that. So in particular, I mean, if I'm to use, just to do that very carefully so that we can be very accurate here, we need to double it.
Yes.
So that in the end, then now you'll have to take, we can work out from this one and say 2x plus 4y plus 4z. Okay? If this is the case, and then okay, we have this. But the dogs are now 4 more. Okay, so that's the same equation equals 46, but the dogs are 4 more.
Yes.
Okay, so if the dogs are 4 more, this is twice x plus 4y plus 4z plus 8.
Yes.
But the 2x plus 4y plus 4z, what is 2x plus 4y plus 4z? It's 46
Yes.
plus 8. And this is what? 54.
Yes.
Mrs. Stubber will see 54 legs. Now, this is more inclusive of all of them because the initial one was just simplified. So this is more inclusive of all the animals, but obviously
Yes.
it's inclusive of the fact that the 46 was used now, which was the total number of the legs in the beginning. Okay, there are many ways to do
Yes.
this question. There are like too many ways to do the question, you know. One way to
Okay.
do the question is to get the X, the Y, and the Z. Like we got the X, the Y, and the Z. What did we get? We got Y, we got X to be 3. The parrots were 3,
Yes.
and then the cats were like 4,
Yes.
and then Z was what? Okay, something we got. Let's see. We got Y equals 4. X was 3. X was 3.
Yes.
Y was
Yes.
4. But Z became 2x. Z was equal to 2x. So I'm just saying there are many ways to do the question. So Z is 2x. So which means that it is 2. X is 3. 2 by 3 is what? It's 6.
It's 6. Yes.
Okay. So we can use these numbers to get the same answer because we already know how many parrots, etc. So with this, we then can then say, if we know these parrots, then we can even be able to check this and say, okay, X are the parrots. One parrot is how many? How many legs does a parrot have?
They have 2.
2, because it's a bird, right? So it's like
Yes.
X. And then the cats, 4.
4.
4's that.
Yes.
I saw. Which means you have 2, 3, 4. Okay, and then the Z is like 6.
Yes.
Okay, Z is 6. I'm just saying you can do this in many ways to get the 54. Okay,
Yes.
just putting the X, the Y, and the Z. And then now, when you point, we have 2 by 3. 2 by 3 is what? It's 6 plus. 4 by 4 is 16 plus. 4 by 6 is 24.
24.
Yes. So what answer do we get? 6 plus 16 plus 24. Can we be able to get that one? So 6 plus
54.
is a 54. Okay. And obviously we just maybe something is missing. We need to be 100%.
No.
Nothing is missing. Okay. Because
Nothing is missing.
experimenting, let's just check. 6 plus 16
22
plus 24.
is 20.
Okay, we're getting a 46. Okay, it's fine. This is correct.
Remember
It's the 46 at the beginning, but the plus the 4. So
plus the 4 dogs.
plus the 4 dogs. So this 46 is correct.
Yes.
It is for the 46 of the beginning when we have everything like that at the beginning. But then would have to come here and then say, so the 46 is correct. And then we have to come back here and then say, okay, the dogs are now 4 more. Okay, so we got how many dogs? 6 dogs. 6 dogs, but we're adding 4 more.
Yes.
So, okay. So, which is fine. 4 more. Out of the 6, there were 6. We get 6 of them, but we're adding 4 more dogs. So here is 4 by, and then now you have 6 plus 4, 10. Okay, this must give us for the 4 more, must add everything to the 54. So obviously we're checking everything we're doing here. So it's 6 plus 16 plus 40. Okay, because now the dogs are no longer 6. They are 6 plus 4 more, so there are 10 dogs now.
10 dogs, yes.
Yeah, okay, so that's interesting. Okay, I just need to always check our answers to make sure everything makes sense. Okay, because this is a word problem, so you need to always check. So now let's deal with the story. It's gonna be 6 plus 16 plus 40.
Yes.
Okay, now this is exactly
different.
62. Yeah.
Yes.
Why is this 62? Let's see. I'm gonna check.
Okay.
I want to see why this is exactly that, because they have to be exactly the
54.
same results. I'm just trying to cross check, because there were 2x plus that, which is 46. Then now there are 4 more dogs, meaning that you'd add 4 more dogs. Therefore, how many legs will there be? Okay,
Mm.
this is silly, but I'm interested in seeing what's let me see what happened here. There's a small error that we must rectify. Yes, here's the error.
Where?
Here's the error. Okay, I'm happy that here we're seeing the error. The error was that what is 4 times 4?
8. Oh, sorry, it's 16.
16. That's the thing. So you see,
Yes.
accidentally we wrote 8 here. That's why these things are not balancing.
Yeah.
Okay, because 4
Oh,
times
well,
4,
yes.
yes, 4 times we distribute 4 that, and then 4 times 4 is 16. Okay.
Yes.
I'm happy that you're saying, okay, you see, by doing it in many ways, it makes sure that, yeah, we correct any mistake. Okay, and then 46 plus that. What is 46 plus that? Because we want everything to balance up.
Okay.
Okay, I'm just
It's 62.
okay, right, okay, yeah, I'm just trying to make sure that we get the correct answers here, please. Okay, right.
Yes.
Now we're gonna add everything. So because now we then said that the 4 by 4 is gonna be 16, so that
Yes.
you can then say 46 plus 16. What is 46 plus 16? 62. So 46 plus 16 is
Yes.
gonna be exactly 62. So yeah,
2.
so this one is going to be exactly 62,
Mm.
62 legs in all. But now,
Yes.
I mean, we did this one here. We added, out of the 6 dogs, then we added 4 more dogs, and we have 6 plus 6
Yes.
is 40. Okay, because these methods, they must give us the same answer. It doesn't really matter what method you use, right? So anyway, just using the calculator to make sure that we make no mistake here. Okay,
Okay.
yeah. So I'm just checking this one now, where we just use the fact that we had got the values of the X was 3 per rods, the cats were 4, and the Z for the dogs was 6. But now we had 4 more dogs, meaning if we have 6 of the dogs, we add 4. We just say 6 plus 4. Okay, and then we multiply
10.
everything. So 6 plus 4, it's 10. 2 by 3, it's
Yes.
6. 4 by 4, it's 16. And then we have 6 brought down, 16 brought down, 4 by 10 is 40. We have 6 plus 16 plus 40. Okay, 62. 62 legs,
Yes.
62 legs. Okay, so I mean, there must be a tie. The answers must be the same. Okay, so 62 legs. Okay, it means that for Mrs. Stubber, now by formula, calculate the number of legs that you will see. Mrs. Stubber will see exactly 62 legs. Right, so Mrs. Stubber will see 62 legs. Think about this, yeah, but that is actually the answer for sure. We've done it in 2 different ways, and we must get the same answer. And this is very, very motivating. It is very, very motivating. It's very liberating.
Okay.
It's very much liberating. Right. It is very much liberating. Any question, any remark, maybe you'd like us to add something, but this is sort of the last part of this particular question. And yeah,
Okay.
yeah, it's the last part of this one. Okay, this one I took it from a past exam paper, this year's January paper. Okay, so
Okay.
yeah, but you can see that if you need to be very alert, you really can make a couple of mistakes there. So
Yes.
you have to make sure that you cross check your answers. I mean, have a calculator can make sure that you get the correct sums, products.
So the use of a calculator is very important
I think it is, because sometimes you can really
because
think, yeah, you
I
can make
can
a
do the whole steps and
yes.
miss with
One
just
number.
one number.
And
Yes.
everything is wrong.
Yes.
You're getting a wrong answer. And you don't want
Yeah.
that. You don't want that.
No.
So yeah, okay. So a calculator, you just cross-check your things. Sometimes you see like here using two different methods allowed us to check the answers because I had not even done the question before myself. But obviously I
Yes.
can see it's very interesting and so just need to always check your work and see exactly what happens. But a very nice question though from the examiner. Right. I think I must thank you for joining us. It was awesome having a discussion. Now, we're gonna continue, but yeah, I'm gonna send more problems. Obviously, we're gonna watch these and repeat these,
Yes.
and then yeah, and then I'm gonna send more questions. There are too many questions that I even planned for today. There are tons of them, but I think that it's enough for today because of time.
Yes.
We spent nearly 2 hours of time ever since we started from the beginning
Yes.
of our discussion. All right, this is awesome because
Okay.
the next thing we're gonna do is gonna be on something different. This one's okay.
Okay.
Similar to the ones that came in the assignment, similar to the
Yes.
ones that came in the assignment
Yeah. Similar
for
to the one. Yes. Similar.
yeah,
The
definitely.
assignment 3. Yes.
Yeah, definitely.
Okay. Well, assignment 4 has been loaded, but what I'm gonna do is I'm
It has
gonna
been loaded.
do
It
it
has
by
been
myself
loaded.
first. Yes, they said they're gonna load it on the 28th. I haven't checked, but I will just verify
Okay,
now.
okay, yeah, yeah. If it's loaded,
I'll
all right.
yes, I will do it by myself first
Yes,
because I've realized that assignment 3, the previous one, it was not difficult as assignment 2.
yes. It was not so
So,
difficult, isn't it?
yes, it wasn't.
Yeah, it
So
was. Yes,
yeah, I felt a bit guilty. So I will try and do
yes,
assignment for first, and
yes.
then I will consult with you where I need help.
Help, yeah, most definitely. Because sometimes they're not very difficult, but
Yes,
sometimes
yes, yes,
challenging.
yes,
Yeah, well, yeah, that's very true. That's very true. Okay, that's
yes.
awesome. It was awesome having a discussion. We keep in touch then. We'll discuss then when we shall meet again. Yeah, but yeah, we shall meet, I'm sure.
All right.
Yeah. Okay. Yeah, but thanks for the discussion today and have an awesome evening. And take care.
Okay, you too. Thank you. Bye.
Okay, thanks. Goodbye, dear. Goodbye. Bye.
Bye.
Right.